Hello Math 2 students, this is the last video this week. This lesson is on rotations. We have so far done translations, dilations, and reflections. And so now we're on rotations. This is the last lesson this week, and you'll have a quiz tomorrow on these transformations. So let's get the vocabulary out of the way. Again, this lesson's title is Rotations. This is the first grading period, second week, fourth day. So we're on Thursday. Vocabulary. Rotation is a circular movement around a fixed point, such as the origin. So these rotations are all going to be rotating around 0, 0. They don't change in size, they don't change in shape. The rotation can be clockwise or it can be counterclockwise. I have a simulation that I'm going to show you, and then we'll come back to the notes. So I'm going to simulate this blue triangle rotating all the way around 360 degrees and then back to 0. So it's at 0 right now, and so it's going to rotate counterclockwise, and when it gets back to where it was, that would be 360 degrees because it's all the way around, and then it's going to rotate back clockwise back to 0. So that's what a rotation around the origin looks like. Don't know if I can get it exactly on 90. If I can't, oh, I had it. There we go. Okay, so this is a rotation counterclockwise to 90 degrees from quadrant 1 to quadrant 2. So you see what happens. The A point kind of, rotates around and drops down to the side here. The C comes from this side all the way up to the top, and then the B just rotates a little bit. So this indicates the rotation of 90 degrees counterclockwise. And so we're going to go 90 more degrees. So this is called a quarter turn, 90 degrees. 90 more degrees stops at 180, if I can get it exactly. There we go. So that's what a 180 degree turn would look like. So again, this is a turn. This is a rotation. It's not a flip over that y equals negative x line like we did when we were doing reflections. Okay, so let's take it to another quarter turn, which is 270. So hard, this thing is way too sensitive, it's hard to get it exact. There we go, 270 degrees. So this indicates counterclockwise, positive 270 degrees. And then go all the way up to 360, and it's back where it started. So let's talk about what we notice with these rotations. So I've put a red triangle here that's going to represent the image, and the blue is the pre-image. So let's talk about the points here. So if we look at the pre-image, which is the blue, we notice that A is at 210. B is at 22. And C is at 62. And then let's look at what we have with the image. The A is at negative 10, 2. B is at negative 2, 2. And C is at negative 2, 6. Okay, so this is a 90-degree rotation. So a 90-degree positive rotation means it's going counterclockwise. So 90-degree rotation. And what happened with the X and the Y? Well, let's look. We've got 210, negative 10, 2. 2, 2, negative 2, 2. That doesn't tell me much. But 6, 2, negative 2, 6 tells me that they switch. The two numbers switch, and the y is the opposite of what it was. So we will make a rule here that it will be the opposite of y and x on a 90-degree rotation. X, y changes to the opposite of y and then x. Okay, so I've moved it another quarter turn, and this is a 180-degree counterclockwise or positive rotation. So let's look at the pre-image again, and I erased everything by mistake. So the pre-image again is 210. B is 22, and C is 62. All right, so for the image, A prime is at negative 210. B prime is at negative 2, negative 2. Yep. And C prime is at negative 6, negative 2. Oh, I see what I did. This is negative 2, negative 10. I put positive 10. So this time what happened with the 180-degree rotation is that XY changed to, what happened? They're in the same order, 6, 2, 6, 2, but they just changed to the opposite. So it's going to be the opposite of X and the opposite of Y. Okay, I left a few things this time so I don't have to rewrite. So I'm going to move this to a 270-degree counterclockwise rotation. And our image, of course, stays the same. Let's look at our our pre-image stays the same. Our image changed, so let's see what our coordinates are for the image. Let's see. A prime is 10, negative 2. B prime is 2, negative 2. And C prime is 2, negative 6. So this time they switched again, so it's Y, X, and the X this time is the opposite. So it's Y opposite of X, or Y negative X. So what I would like to do, since we actually already established some rules looking at the simulations, is I want you to skip to this part of your notes right here, and we're going to go ahead and write in the rules for each of these situations. So let's talk about counterclockwise, because those are the ones we just looked at. So let's put in 90 degrees counterclockwise right here. And the 90-degree counterclockwise rule that we discovered on our previous section was that xy becomes negative y, or the opposite of y, x. So you switch these and you make this number the opposite of what it was. Interestingly enough, if you are going 270 degrees clockwise, which it's the same thing as the 90 degrees counterclockwise. So if we look back over here, if you can imagine, the 90 degrees clockwise going from quadrant 1 to quadrant 2 would be the same as the 270 degrees. I'm sorry, I said clockwise, I meant counterclockwise. So 90 degrees counterclockwise would be the same as 270 degrees clockwise. So going back over to our notes, we're going to write 90 degrees counterclockwise is the same as 270 degrees clockwise. So we're going to write the exact same rule for these two situations. And then I'm going to change colors and look at 270 degrees counterclockwise, which was what we had done. Let's do 270. There's 270 counterclockwise. But that would be the same as 90 clockwise. Clockwise is this way. Counterclockwise is this way. And it has to do with the old clocks, like the one I have on my wall in my classroom. So 270 degrees counterclockwise, we had already discovered, is y negative x. And then we're going to write over here on the 90 degrees clockwise, these two blue ones are exactly the same. Because unless you have an arrow telling you which way you went, you don't really even know if it's 90 degrees clockwise or if it's 270 counterclockwise. You don't know unless they've drawn an arrow for you, and it really doesn't matter anyway. So this is going to change to y and then opposite of x. Now, 180 degrees, do this one in green, 180 degrees would be the same either way because that's halfway around. So 180 degrees, we'll go ahead and put the rule for this too. And that's just going to be that they stay in the same order, they just change to the opposite. So positive becomes negative, negative becomes positive. Okay, so now that we've got our rules written down, let's go back to this section of the notes. So in example 1, I have graphed the pre-image and I've put the ordered pairs here. And what we want is a 90-degree counterclockwise rotation. So it's going to go from, sorry, I put quadrant 1 to 2. It's actually 2 to 3. So it's going from quadrant 2 to quadrant 3. So it's 90 degrees counterclockwise. Well, what was our rule? Our rule is opposite of y, x. So I'm going to go ahead and do the ordered pairs. So I'm going to put, that's going to be a negative 5, negative 2, negative 4, negative 1, and negative 3, negative 2. All right, I want you to go ahead and graph this and go ahead and pause your video. Actually, I'm going to pause my video and I'm going to graph it. You pause and see if you can graph it and then come back. So that's what it should look like. So to determine if a rotation has occurred, look at the points. If the points have turned, then you know it's a rotation. If they have flipped over a line or over an axis, then that would be a reflection. Okay, next example, example 2. Let me get some things written in here and I'll come back. So for this one, I'm not going to graph these. I'll let you graph them. I want to see, can we tell just by looking at the points what type of transformation has occurred? So we have A is negative 2, negative 2, A prime 2, 2. That doesn't tell me much because they're the same numbers, just positive and negative. We have negative 1, negative 2, 1, 2. Okay, so this is x, y, and then opposite of x, opposite of y, which tells me this is a 180-degree rotation. So you can graph these if you want, but we can tell just by looking at the ordered pairs what has happened. Okay, this one says rotate the figure 270 degrees counterclockwise. And we know that that is the same as 90 degrees clockwise. We're just going to make a note up here. Same as 90 degrees clockwise. Okay, the 270 counterclockwise. The rule is that it's going to be y and then the opposite of x. So they're going to flip positions and the x is going to become its opposite. And we're just going to do the ordered pairs again. You can graph this over here. I'd just like to, in the interest of time, speed this up a little bit. So I'm going to switch these around and the second number is going to become its opposite. So 0, negative 2. This is going to be negative 2, negative 3, and negative 3, 2. All right. Okay, again, this one says rotate it 180 degrees. So we can do the image ordered pairs by just changing each of these to their opposite. So 4, negative 3. Let's write the rule up here though. Opposite of x, opposite of y. That's going to be 5, 2, and 0, 0. If you want me to show you the graphs of any of these, I can do that during class tomorrow. Okay, so this is your practice, and I want you to try these on your own. Rotate 90 degrees clockwise. Remember, that's the same thing as 270 degrees counterclockwise. You have the rules in front of you. And then I want you to look at this transformation. What you can do is just take one of the points and look at how it's been rotated. You have to really look at how it's been rotated, though, and write the rule for the rotation there. So I think that's it for right now. I'm going to stop because this video is getting too long anyway. So, get these notes done and bring them with you to your online session or to your in-class session tomorrow, and we will go over these and review everything.